All right, as always, if you guys have questions, go ahead and put them in the chat or unmute yourself and talk to me as we go through this. We are continuing on with the same idea that we started with on Monday, and that is that we are estimating the area under a velocity curve. So given a rate of change, the area under that will tell us the total distance or total change of the function, the original function, over a given interval. On Monday, on our first lesson, I was referring to them as LRAM, RRAM, MRAM. Please understand that those are notation specific to our book. It's common, but it is not like the official calculus way of describing that. And so I do want to point out that there is actually another name for this, and that is a Riemann sum. We haven't been introduced to that word officially, but we will in a couple days, is this idea of what's called a Riemann sum. And so a left Riemann sum would be the same thing that we did on Monday called LRAM. And it's just a rectangular approximation method for finding the area under a curve. So just know that some of your questions will end up referring to it as a Riemann sum. And we haven't been introduced to the official notation for that, but we will be soon. Okay, going ahead and jumping into our notes here. Our first example, I'll kind of read through it slowly so those that don't have note sheets can get that jotted down. But it's talking about a car traveling so that its speed is never decreasing, which eventually is going to be important to us, but just they throw that in there so that what we are doing will not ever be wrong. Its speed is never decreasing during a 12-second interval. The speed at various moments in time is listed in the table below. So the thing you're going to notice is a big change from what we were doing. What we saw a little bit at the end is that we're just going to practice a little bit more of these estimations from a table of data. Okay, so given a table of data, so in this table of data, they give us time sample speeds at time equals 0, time equals 3, 6, 9, and 12. Notice on this particular table of data, it's a nice even spacing between those times of 3 seconds each. And they give us the speed in feet per second. The first question asked of us on this particular example is to sketch a possible graph for this function. As I'm sketching this graph, just a reminder that we kind of want to glance at the numbers in the table as we're getting this set up. So my time is going to be my, I'm going to go off to the side here a little bit. My time is going to be my units along the bottom, and that's going to go from 0 to 12. And this is my time in seconds. Okay, and then going up the side, it looks like I'll need to get to a height of 65 there. So as I'm marking this, maybe I'll go by tens here. So that'd be 10, 20, 30, 40, 50, 60, 70. Let's see, oops, that's wrong. 40, 50, 60, 70. And this would be labeled as my speed, which is done in feet per second. And then I can just draw those dots in the picture. So at time equals 0, we were up at 30 feet per second. At time equals 3, at 37. At time equals 6, we're up at 45. Time equals 9, we're at 54. And at time equals 12, we're up at 65. So sketch a possible graph for this function would look something like this. Mine kind of looks linear. We don't know that it's linear. Mine just kind of ended up in a straight-ish line. And then part B, so it says estimate the distance traveled by the car during the 12 seconds by finding the areas of 4 rectangles drawn at the heights to the left endpoints, or the left Riemann sum. So as we look at our time that starts at 0 and ends at 12, if I need to split that into 4 equal rectangles, it actually is kind of nicely done for me. So half would be at 6, cut each of those in half. So it looks like each of my rectangles will have a base of 3, which matches the data they gave us. And then from this, I'm supposed to use my left endpoint. So my left endpoint would be 0 for this first rectangle. Again, if you like the visual, go ahead and draw that in your picture. But that would be the rectangle that's going from 0 to 3, has a base of 3, and we're going to use the left end of that as our height. So a base of 3 and a height of 30. And then we keep going here. So my next rectangle, again, would have a base of 3, which is going to connect from 3 to 6, and we're going to use the left height. So we use that height at 3. So again, if you like the picture, since we have the picture, we can use it. Base of 3, height of 37, get that value from my table. Next one, here's my base of 3, height using left side. Oops, that doesn't, I didn't draw that very good. Should be at the height of 6. So here's my next rectangle. We'll use the 45. This should be our height at 9. I didn't draw this very good. So we use a height of 54. So you guys will grab your calculators and you'll type all that in. And again, you're welcome to type all that in. You could also, as an option, type in 3. Since that's the GCF here, I can pull that GCF out front and just do the 30 plus 37 plus 45 plus 54. Gives you the same answer, so it doesn't matter which way you choose to type that in. And ultimately, we come back up here and we get an answer of 498. And labels become very important. So it says estimate the distance traveled. So what we just did is we took a base of 3 seconds times a height. So we'll just look at this first one, times a height of 30 feet per second. And again, those seconds cross off, which would happen with all of these, which means our overall label, which matches distance traveled, is in feet. We're taking feet per second times seconds, and the seconds cancel, leaving us with just feet. So this should look familiar, very similar to what we did yesterday. So using the same data, I'm going to give you guys a few seconds to try out this next one and see if you can, and I'm taking the picture away, so try without the picture here. Give you a few seconds to work ahead of me here. On part C, which is 4 rectangles again, drawn at the right end endpoints, and then part D asks you to switch it up to 2 rectangles using the midpoint. So I want you to think about that one as well. Give you about a minute or 2 here to try those out and see if you get the correct answers. All right, let's see how you did. Again, I don't have the picture to look at this time, but I know that we breaking this up into 4 equal rectangles like we did last time. My first rectangle would be the one that goes from 0 to 3 or has a base of 3. But if we're using the right endpoints, this time I'm going to use a height of 37 for that. My next rectangle would go from 3 to 6. So again, a base of 3. That base is the distance between those time values. And using our right height would be a height of 45, 3 height of 54, and 3 height of 65. Should be how you set up the right Riemann sum. And when I type that in my calculator, overall answer of 603 feet. And the last one, so now it's changing to 2 rectangles. So if we have only 2 rectangles, from 0 to 12, if I break it into only 2 rectangles, we'd have a rectangle that goes from 0 to 6, and then we'd have another rectangle that goes from 6 to 12, just 2 rectangles. And it says they use the height of the midpoints. So if we look at our midpoints are going to be the value that falls right in the middle of the endpoints, my endpoints being 0 to 6. My midpoint would be 3, so the heights we would use on this would be the 37 and the 54. So the base will change. My base length is now 6. Oops, height of midpoint height, so 37. My second rectangle also has a base length of 6, and this time height of 54. So there's your midpoint Riemann sum. They will have to change up the number that they're asking you to use, because from a table, we would not be able to figure out like what the midpoint height is between 0 and 3. So it wouldn't make sense for them to keep it at 4 rectangles, because if it's not in the table, I don't get to guess what it is. It's not exactly halfway between those values. So they would have to change it up so that it's an actual value that you see in the table. And again, typing this into my calculator, my estimate for the amount of feet that we travel is 546 feet. So this is kind of where we left off on Friday, being able to do these Riemann sums or this LRAM, RRAM, MRAM from a table of data, and then connecting that, okay, to then doing this from a function. So just some kind of extra examples here. This time, not a table of data. It says, given the function y equals x squared minus 1, estimate the area bounded by the graph of the curve and the x-axis from 0 to 2. And then they're asking us to do it 3 different times. The first time we're going to do a left Riemann sum with 4 rectangles. Second time we're going to do a right Riemann sum with 4 rectangles. And the third time we're going to do a midpoint Riemann sum with 4. Now I will encourage you to have your calculators ready. The numbers get a little ugly on this one, and you might want to make notes for yourself as you are doing this as to where these numbers are coming from. So the first thing I did for myself on this was just I gave myself a picture so I could kind of figure out what was going on. So we're supposed to be graphing this on our x-axis from 0 to 2. And so that's exactly what I would draw here is go from 0 to 2 along my x-axis. And then draw this function. And so to put these points on here, I'm just looking at this function. What is our function if I plug in 0? So if I plug in 0, I'd have 0 squared plus 1. So at 0, I'd have a point at 1. And then I just use the nice numbers in here to start with. So at 1, if I plug 1 in, 1 squared is 1, plus 1 is 2. And I plugged 2 in. 2 squared is 4, plus 1 is 5. And what we're seeing is just that little parabola. It's a parabola moved up 1, right? Oh, that got kind of wavy. There, that looks better. Okay. Now, the thing is we have not seen having to do this, but it does get a little bit ugly. It says left Riemann sum with 4 equal subintervals, but we only go out to 2. So if I'm supposed to have 4 equal subintervals right now, if I were to just go from 0 to 1 and then 1 to 2, that'd only be 2 rectangles, which means I need to cut each of these in half. And if I do that, this would be what? 1/2, and this would be 1.5 or 3/2. So there's going to be my bases. So my base length when I do this is going to only be 1/2. So for this first rectangle right here, I've got a base length of 1/2. I'm supposed to be using my left-hand side, which would be 0. Now I happen to know what that one is because we did that right here, right? So the height of that first rectangle is just going to be 1. And then we keep going across here. So my next rectangle, again, only has a base length of 1/2, but now I just use the left-hand side for my height, but we didn't figure that out. I don't know, I don't have that in my list over here. So we actually have to go figure that out, is I need to figure out what f of 1/2 is, because that's my height, right? So 1/2 squared plus 1. And so as I go do that, 1/2 squared is 1/4, plus 1 would be 1 1/4, or 1.25. 1 1/4. That's where I'm getting my height, is I'm just plugging whatever my height was supposed to be, whatever value I was using to find that height into the function. Okay, so continuing on, my next rectangle would go from 1 over to 1 1/2. I'm supposed to use the left-hand side. We have that one. So I'm using that left-hand side for my height. Again, base length of 1/2, height of 2. And our last rectangle is going to go from 1 1/2 to 2. Use the 1 1/2 as my height. And again, I'm going to have to figure out what that is. So I'm plugging 1 1/2 into my function. Okay, now I understand that these are a little ugly. First of all, 3/2 squared is 9/4, right? I square the top, square the bottom, and add 1 to that. Well, that's what, 1 3/4. I'm sorry, 2. Let me try that again. Math stuff. 2 1/4 plus 1. Although I would love to say that you would always get a calculator, that really is something you can do by mental math. So I do want you to be prepared to do that. It has a base of 1/2 and a height of, 3.25 there. Move this stuff out of the way a little bit. Okay, and then typing that into my calculator, and again, maybe it's going to be easier for me to do, especially if I had to do this via mental math, is I might pull that 1/2 out front and do 1 plus, again, 1 plus 1.25 plus 2 plus 3.25. It doesn't matter which way you go about this. Either way, type that in, whatever I get, 3.75. All right, second question asks us to do the same thing, but with our right Riemann sum. So this time we're going to use the right endpoints for our height. So as I'm doing that, for this first rectangle, I would have used the 1/2 as my height. So I'd get that green one, same base, but this time my height would be from f of 1/2, which was 1.25. Second rectangle here, again, using the right side as my height. So I would use the height at 1. Which would be right here. Third one, again, we kind of already did the work to find these values, so I can just go grab them. My height would be right here of 3.25. And my last rectangle, base of 1/2, height at 2, which is here. So don't overdo the work. We've already done the work, just go find it again, which is kind of nice if I jot it down for myself so I remember what I found. Go type that into my calculator. This time I'm getting a bit of an overestimate, but it is 5.75. All right, now let's talk the midpoint Riemann sum with this one. They still want us to do 4 subintervals, so I'm going to redraw this picture so you can see a little bit, and I'm going to see. We had a dot at okay, so we had broken this up into the four different rectangles here. That would be 1/2, 1, 3/2, right? And we're supposed to use the midpoint this time. So although my first base is going to, undo that. Although my first base is going to go from 0 to 1/2 or have a length of 1/2, The height is a little trickier to find. So let's talk about the height, because the height needs to be at the midpoint of this. Well, what is the midpoint of that? Would be at half of a half, or at 1/4. So then I have to go evaluate what f of 1/4 is. So this one just gets a little bit ugly here. And so now go grab your calculators. Go type that into my calculator. F of 1/4, we find out is going to equal 1.0625. And we repeat that process. So then I go to my next one, which still has a base of 1/2, but the height comes from exactly halfway between there, and halfway between 1/2 and 1 would be 3/4. So now I'm going to go evaluate to find, oh, those are my heights, right? Those are the heights of our rectangle here. So now I'm going to go evaluate f of 3/4. So when I go type that into my calculator, I get this ugly number, 1.5625. And we keep going. So halfway between 1 and 1.5 would be 1 1/4. And go type that in, f of 1 1/4. Into my function. So it can get ugly, and obviously on this one we would need a calculator to be able to do this. There's my height at 5.625. And our last one, so halfway between 1.5 and 2 would be 1 3/4. And go type that into my calculator. There's our last rectangle. So the midpoint, you might have to do a little bit of work to figure out what the midpoint is. Okay, so what if I don't know what the midpoint is between two numbers? You add them up and divide by 2. It's the average of those two numbers. So just remembering your little algebra skills here on how I would go about doing this. And that last one has a height of, I'm kind of running out of room here. So I typed all that into my calculator and overall got an answer of, oops, not 6, 4.625. So what I want you to get out of this last example is, okay, well, when it doesn't fall nicely, how do I find the midpoints? You can add up the two endpoints and divide by 2. That's the midpoint of that section. And then also, if I don't know the height, you plug it into the function. Okay, and again, those can be some ugly numbers, and obviously on ugly numbers, we're going to get a calculator. All right. I'll let this page sit up here for a minute so you can get those all written down here. Okay, last thing we are going to do today is look at one of these that ends up giving us a little bit of initial conditions to start with. So again, if you need to be copying this down, try to do that while I'm reading it and explaining what we're looking at here. So we're starting with a situation where we've got a table of data given to us that is talking about water flowing into a tank, and it's over 12 hours. The rate at which the water is flowing into the tank is given in the table. And the results are shown below, and they are listed in gallons per hour. So our rate of change is gallons per hour. And then the part at the end, always read the directions. This can give us some very important information. It says the tank contains 150 gallons of water when time equals 0. So then part A says, estimate the number of gallons of water in the tank at the end of 12 hours by using a left Riemann sum. So we know as we do this, we're going to pick the left number. with 3 subintervals and values from the table. So looking at this initially, it's nicely set up to break into 3 rectangles. My first rectangle would go from 0 to 5. My second rectangle would go from 5 to 8. And my last rectangle would go from 8 to 12. And again, if you're not seeing this, draw yourself a picture and draw in the rectangles. Then you can absolutely do that. So the thing we are going to see in this particular set of data that we have not seen before are 2 things. One of those things is it gave us a little bit of initial conditions, is that the tank already had 150 gallons of water in it. The second is that it is not equally spaced from 0 to 5 and then from 5 to 8. Well, the first one rectangle has a base of 5. The second rectangle has a base of 3. And so we do have to pay attention to the change in the size of the rectangles that they give us. So as we look at this from time equals 0 to time equals 12 hours, we can estimate using that left Riemann sum. So for my first rectangle, I'm going to use a height of 8. It has a base of 5, height of 8. My second rectangle has a base only of 3, and again, using that second height. And my last rectangle from 8 to 12 has a base of 4, using my left height. So this is exactly what we've done every time, but the question was estimate the number of gallons of water in the tank at the end of 12 hours. Well, this is going to tell us how much we added during that 12 hours. But this is where we have to pay attention to the directions. We started with 150 gallons. So then we're going to want to add that to what is put into the tank during the time period. So this would be our overall amount of gallons in the tank at the end of 12 hours. So type all that in. We get 253.6, and then labels become very important. Remember, as we are looking at each of these, we are taking our time versus our hours times our gallons per hour, or look at estimate the number of gallons. It'll tell you how to label it. We have 253.6 gallons at the end of 12 hours. Okay, we are going to do this one more time, same situation, but this time you guys are going to have a right Riemann sum. When you finish today, you are going to put your answer in the chat and tell me how many gallons are left at the end of that time. When you're done with that, you are, and I have told you that you are correct, your assignment is posted on Google Classroom. If you have the means to print it out, you are welcome to do so. If you don't have the means to print it out, you need to do your work on a separate piece of paper, clearly numbered. And here's what I'm going to tell you. If you give me just, like on this example on part A, if you give me 253.6, and do not show this line of setup where it says show the computations, this would be showing your computations. I am not going to give you full credit for this assignment. So make sure you show your setup and then you also give your answer on that. All right, I will leave this up here so you can see this. I'm going to end my